So in this first section, we're going to take a look at points, lines, and planes. It's our first section into our Intro to Geometry unit, and it actually, for the most part today, should be a lot of things that you would have heard of or seen at some point over the last couple of years in your math classes. But we want to make sure we can build based on that knowledge you already have in order to move forward. So if you take a look at it in Schoology, maybe follow along as you're filling in the note sheet yourself. I have this one kind of filled in already for you, and I'm just going to kind of talk about it as we go. So if we first look at defining what a point is, it names a location, it has no size, and the way we represent it is by a dot. So if you see a dot, it means it's a point. And then how do we name that point? It's always by one single capital letter. So our point here might be point T. So it's a capital letter T. What about lines? A line we know is a straight path. It doesn't have any kind of thickness and it extends forever. So it goes on infinitely, and that's why we have the arrows saying that that continues forever. A couple of examples of some lines. We have one labeled LG, and then we have another one that has a lowercase cursive h. Those are the two different ways that we could name them. You could either name them like so, two capital letters with the line above it, including the arrows on both sides, or we could name it with a lowercase cursive letter, like the letter H. Then we have a vocab word, collinear. If something is said to be collinear, it means that it's on the same line. Think about the word co, like if you co-host, you're both doing it, it's like you're the same. And then linear, of course, is line. So on the same line. If we were to draw a diagram that has 4 different points, A, B, C, and D, that are collinear, that means all 4 of those points have to be on the same line, like that example. Going from a line to a line segment. A line segment is a part of a line, so then there are actual endpoints. So the line segment stops on 2 different ends. So the example here is JD. And how would we name it? Similar to a line, but we don't put the arrows above it. So it's 2 points with a bar on top because those are the 2 endpoints of that segment. Think back, what is array? Array is a part of a line that starts at an endpoint and then extends forever in one direction. And that direction doesn't matter. So our examples here, we have an AB that extends all the way to the right, and then we have an AB that extends all the way to the left. But both of those are actually named the same because the endpoint is A in both of those. So we name them AB with array on top of it, and it's always going to be the capital letters. So just recapping that quick section, answer these 3 questions on your own. I would say pause the video, and then I'm going to reveal the answers. So go ahead and pause right now and complete those 3 questions. Welcome back. If we look at some possible solutions here, here's what we have. So 3 different ways we could have named that line. We know we use 2 points, 2 letters, and then it has the line with arrows in both directions on top. So any combination of those would represent a line. So those are the 6 different possible ways we could do it, and we always do it with 2 letters. Number 2, what's the difference between array AB and array BA? Well, you always name the endpoint first. So the first one, AB here, would look like this because A is the endpoint. It doesn't matter which direction it's going, but A is the endpoint right here by itself. And then the other one would be ray BA. Which contains more points for number 3? We have a line AB, and then we have a line segment AB. If we move on to planes, think about a plane. I've always described it as like a sheet of paper, a flat surface, two-dimensional, but it extends infinitely far. So it goes on forever. So it's a flat piece of paper that extends infinitely long. So if we're thinking about the room that you're in right now or a classroom, what are a couple of different planes? So if you're looking around, you see probably the surface of a desk, maybe the screen of your phone or iPad or TV, the walls, a door. A lot of those different things are examples of a plane. Maybe there's a poster on the wall. That's a flat surface. So those are all examples of planes. How do we name planes? Well, when we do lines, we always try making it the same way in order to make it easier to represent and like kind of refer to them. Same idea with planes. We can either name them with 3 non-collinear points, so 3 points that are not on the same line, but are on that same flat surface, or we would use it with a cursive uppercase letter in the corner. So we would just call this one plane R, so it's a capital R there, or 3 non-collinear points, so 3 points that are not on the same line. So an example would be A, B, and E. They're not on the same line, so we could label it like that. All capital letters, and there's no symbol above it. It's just 3 letters, and that's a plane. If we think about 2 lines, when they cross, they meet at one single point. Well, what happens when you have 2 planes that intersect? So look at this diagram. Remember, always picture a plane as being a sheet of paper. We can label that sheet of paper with a bunch of different letters. So I have like a C and a D and a F and E, A, B. Those are all different points on there, just to kind of help us see it better. Well, where do those 2 planes intersect? Well, this whole piece of paper crosses with this whole piece of paper right here. And what is that? Since it extends infinitely many directions, it's going to be the line AB. If we look at what planes intersect, we would say, since here's one point D, B is one that's on there, and E, since that's not collinear, we could label it DBE. And then the other one, we have a point like a C, an A, and an F. Or I could have used B instead of A. And then that's where they cross. If you're looking at the room that you're in, what are a couple of planes that don't intersect? So if they don't intersect, then we're thinking they're parallel. So you might think the floor and the ceiling. Those are never going to touch. Those are parallel, so they won't intersect. So hopefully that kind of makes a little bit of sense. If you still have some time left over before we come back as a group, you could start and take a look at that homework number 2 today. Otherwise, you can always chime in and ask me any questions. See you soon.